Hello, our project is mining opinions from comparative sentences. This is done under the course Information Retrieval and Extraction, mentored by Satrupa Guha, under the guidance of Dr. Vasudev Verma. Let me introduce this project. Given a comparative sentence, the objective of this project is to determine which entity is preferred by the author. It has very wide applications in today's world, and this is particularly important for analyzing customer reviews, forum posts, blogs, etc. For this project, we have taken the sentence structure and broken it down into entities, comparative words, and the feature. From the example, you can see that the camera X and camera Y are the entities. Longer is the comparative word. It is denoted by C in the rest of the presentation, and battery life is feature. It is denoted by F. The comparatives are divided into various categories. One of the categories is type 1 and type 2. The type 1 consists of the words ending with ER and EST. For example, better and best. Type 2 are the rest of the comparative words. Another type of categorization is increasing and decreasing. It gives the tone of the sentences. For example, if the words containing more and longer give a increasing tone, and the words like less and fewer give a decreasing tone. Another categorization is opinionated and context dependent. Opinionated indicates a direct meaning irrespective of the context. While for context, take an example, say higher. If higher is used with mileage, it gives a positive meaning to the sentence, while if higher is used with risk, higher risk gives a negative meaning. These are the related works, but our work is related to the paper Mining Opinions in Comparative Sentences, published by Liu and Ganpati Bhogla. The implementation of the algorithm is as follows. We have divided it into two cases. The case 1 is for the type 1 comparatives, which is further divided into 4 subcases. 1A consists of where the comparative word is opinionated. Consider the example, car X is better than car Y. Here better is the comparative word, and this is implemented using a word list of positive words and negative words. Consider the next case where comparative word is not opinionated but feature is opinionated. The example is car X generates more noise than car Y. Here more is the comparative word and noise is the feature. For this we have used 4 possible cases, that is the comparative word is increasing or decreasing and feature is positive or negative. Depending on the combination of these, we decide whether it is entity 1 or entity 2. The next case is where both comparative word and features are not opinionated. Here, consider the example, camera X has shorter battery life than camera Y. Here, shorter is the comparative word and battery life is the feature. Here, we have calculated with a formula called one-side association, which checks the pros and cons dataset and considers the probability of occurrence of the comparative word and feature. The next case is where the comparative word itself is a feature indicator. Consider the example, camera X is smaller than camera Y. Here smaller is the comparative word which indicates a feature. Here we have calculated the occurrence of the comparative word in the pros and cons dataset and decided upon which entity is preferred. Case 2 is where the comparative word is of type 2. Here we have again divided it into 2 subcases. One where the adjective and adverb in the comparison is opinionated and where it is not opinionated. The approach for the first case is similar to the approach in 1B, that is we have considered comparative word and feature, and approach for the second case is similar to 1D where we calculate the OSA in it. These are the screenshots of our application. Here we have 2 modes, manual and to select a file. When we select a file, we get the output path of the file. Consider the demo. car X is better than car Y. These are the entities and comparative words filled. When we click on OK, we get the preferred entity is car X. Consider another example. Camera X has shorter battery life than camera Y. Here, entity 1 is camera X, entity 2 is camera Y, comparative word is shorter, and feature is battery life. We click on OK and we get the preferred entity is camera Y. The results for these are entity 1 has got F measure of 0.93 and entity 2 has got F measure of 0.65. Since in the dataset the preferred entity was entity 1 for maximum of the data, there is a significant difference between entity 1 and entity 2 F measure. You can refer our code in the following link. Thank you.